Label this guy. I'm going to call that A, angle B, angle C. All right, right now I know I'm missing angle C. Well, let's stop. Let's first decide if we're going to use law of sines or law of cosines, and that's going to be determined by the information they gave me. They gave me two angles and a side. Anytime they give me two angles and a side, I don't care where the sides are or the angles are, it's automatically going to be law of sines. Yeah, we can go ahead and specify that it actually is angle side, but we didn't even need all that information. We just needed to know two angles and a side and said, I'm going to use the law of sines. And just for a quick review, law of sines tells me if, and we're going to be looking for sides, so we're going to put sides on top. So we're going to be using the A sine of A. That's going to equal side B over sine of B. And that's going to equal side C over sine of C. And all we have to do is find those missing sides, because that missing angle is going to be real easy. A triangle is 180 degrees. I know two of the angles, so you know that you don't have to do anything to get this except do 180 minus 72 minus 64, which should come out to 44 degrees. So like I said, all we have to do is find side B and side C if I'm looking for sides. And I'm using the law of sines, we put our sides on top. So that was just a little note to myself on what I was supposed to be doing. Okay. So now what I'm going to do, and what I do, is I generally think about, well, if I'm solving this, that must mean I know one of these. I know all the information to plug in one. And that is going to be angle A with side A. I have the angle, I have the side, so I can plug side in, angle in, and I can solve everything else from there. So let's start with side B. Let's go ahead and solve for side B. Well, I don't know what side B is yet, so I'll put B over sine of angle B. Well, angle B is 72 degrees, so we'll just put a 72 in there. And that's going to equal our side A, which is 13.6. over our sine of A, which was 64 degrees. Yeah?
Isn't the angle sine C 44 degrees?
44. Did I say 40? Did I say 40 or did I? I remember saying 44, but yeah, you're absolutely right, because it's 2 plus 4 gives me that 6. Yep, I should have said 44 degrees. All right. I guess it's just been too many times saying the same number. Now we're just going to use the fact that I can multiply both sides by sine of 72 to get my B. So my B is actually just going to equal sine of 72 degrees times that 13.6 over sine of 64 degrees. And when you plug that in your calculator, you're going to come out to about, I think this was the 14.4. And once I do one of them, and it makes sense, hey, this is 13.6, it makes sense that B is 14.4. If this came out to like 1,063, I'd be like, made a mistake. Or if it came out to like 0.03, I'd be like, did something wrong. Came out pretty reasonable. So that tells me that I'm going to do C the exact same way. So we're going to do C over the sine of 44 degrees, probably not 40 degrees. That's going to equal... I always just use the same thing. I use the 13.6 over this because that was given information. I know I didn't make a mistake on that. If you wanted to, you could use the B with the 14.4, but then you have to be 100% sure you got this one right. All right, if you made any mistakes here, then you're going to duplicate the mistake over here. So I always use the given information. So I'm going to use that 13.6 because that side was given to me. The angle was given to me, sine of 64 degrees. I'd multiply both sides by sine of 44 degrees, and my C would end up being about 10.5. Make sure you know how to do these. All right, these should be the easiest of the problems, basically. Especially one like this. It's just angle, angle, side. You solve this angle, and then you just have to plug in. Law of sines is the easiest law to remember. Side over the angle of the same side. Law of cosines, though, are a little more difficult to remember, so those take a little extra, little step to it. But do remember that you're going to be able to have a note card on your test next week. All right, don't fill it up with nonsense. Fill it up with crucial. And what I mean by nonsense is some people spend so much time putting examples down that they bury all these important formulas, and then they can't find it on their card and they get it wrong. All right. So spend most of your time doing the important formulas, and then if you have some more extra space, then put an example here or there. Okay. So we're good on that? Minus the 40 and the 44. Okay. Questions on the homework? Charlie.
Number 17. I think bring in my calculator and calculating the
Okay, number 17. Let's just look at 17. I think someone else had a problem with that. I don't remember if it was 17 or not. Let's look at it and we'll find out. I think I did it here. Hopefully this one doesn't have all the answers on it. So number 17, I'm supposed to write each complex number in its trigonometric form using degree measure for the argument. So I'm assuming you did... what part did your calculator spit out wrong?
I was trying to find what
the degree was?
Yeah.
The degree of the measure? Okay, with these, the easiest thing you can do is draw yourself a picture to make sure the angle you get makes sense. So if I draw the picture of this, it would be, my real is -3, so I'd go -3 and I'd go +3. So I'd end up somewhere up here. I'd go somewhere up there, and if you could you tell me how you solved this length? Did you do the A equals R times cosine theta?
Yeah, that's what I did.
Okay. And then your R should be 9 plus 9, so square root of 18. So you had square root of 18 for your R. So you would have came up with square root of 18. That's going to equal, oh, that's your R, I'm sorry. You should have had on there -3 equals square root of 18 times the cosine of theta, right?
Yeah.
That's what we had. And what did you come up with theta equaling?
That's where it gave me the error. I tried figuring out
Oh, it just came up with an error?
Yeah.
I'm trying to think why I would give you that error. Oh, it's bigger than 1. No, it's not bigger than 1. Can someone duplicate that? I don't have my calculator on me. It works? I just don't have my calculator, so I can't check it. So you'd come up with theta equals cosine inverse of -3 over square root of 18. Okay.
135.
135. Does that make sense that this angle is about 135 degrees? Does that make sense for people that are goofing off? And I asked that because sometimes they'll come up with, it might have came up with, I don't know, 45. Or it might have come up with 45. That would have told you that, hey, that actually found this angle, and you'd have to do 180 minus 45. So draw yourself a picture. That way, if the angle doesn't make sense, you can figure out what angle it actually found. Because sometimes this will find our reference angle. So if this would have came up as 45 degrees, you'd be like, oh, okay, it's just 180 minus 45. But if you didn't have this drawn, you wouldn't know it was right or wrong. You wouldn't have a clue whether that angle it provided you was right or wrong. But that answer your question? Good. Other questions? Yeah?
15.
15? Oh, right there. Are you just looking for... Okay, so 15 and 13 are one of those oddballs that once you know what they're asking, they're actually pretty easy questions. So we don't have any real information, right? Our real is actually 0 because it's 0 plus square root of 3i. So that means we're actually just going up square root of 3 units. How long is that line? What was that? Well, yeah, we'll just leave it as square root of 3. So the length of this line is square root of 3, right? Yeah, it's just square root of 3. So that means our r equals square root of 3. And what angle's right here? 90 degrees. So that means our theta equals 90 degrees. And then we just plug in that information, right? Because if I know my r, it's just going to be square root of 3, or r times the cosine of theta, which was 90, plus I times the sine of that same theta. Does that make sense?
Yeah.
And it'll be the same thing here, except we have a real, and it'll be 0 degrees versus.
Yep.
Good? Good on that? And what's cool about that is you can see why we don't have any reals. Because the cosine of 90 degrees is 0. The cosine of 90 is actually, so 0 is actually here. We have 0 of the real. Good? Other questions? Any questions at all? Past assignments or anything? Something that doesn't make sense? Okay, don't forget about the test next Thursday, right? Don't put it off. We'll have 2 review days, which is nice, but I'm only here for 1 review day. I'm only here for Tuesday's review day. So as soon as I'll hopefully have your review handed out on Monday, so take some time, look it over, and see what doesn't make sense. Okay, then otherwise we'll just get right into today's lesson. We are the 3rd period, so we're there. Okay. So today we're just going to talk about the product and the quotient rules that apply to multiplying and dividing complex numbers when they're in their trig form. Now you don't need to write this, but normally if I had something in, don't write this at all, this actually doesn't belong there at all, but let's say I had something like 3 plus 4i, and I multiplied that by 6 plus 7i. We'd have to go through all that strain of factoring, or not factoring, but distributing, FOIL, and all that kind of stuff, and seeing what eliminates. We don't have to do any of that when we're dealing with trig. So as soon as it's in this trig form, it becomes really easy to multiply and divide the 2 items. So we're going to talk about the product rule first. So the product says, well, look at my z sub 1 and z sub 2. Those are what we're going to have standing for, and they're obviously in trig form. So if someone asks you to do z sub 1 and multiply it by z sub 2, this is exactly what you would do. You would take your modules, that's your R1 and R2. Remember yesterday I had you write down that those are actually called modules. So our R values are modules. I'm just going to multiply those together. So I'm going to do R1 times R2. All right, good start. Now we're going to take that cosine, add it in there. We're going to add the arguments. The arguments are our 2 thetas. So we're going to add theta 1 plus theta 2. And whatever I do to cosine, I'm going to do to sine. So it's going to be plus I times sine of theta 1 plus theta 2. I ran out of room, but that is the end. That is the end of that. I'm going to go ahead and shift this over a little bit. I might lose some of my z's, but you should already have those down. It might get in my way in a second. There we go. So when I multiply complex numbers, when they're in the trig form, we just multiply our R values, which are also called our modules. Those are also called our absolute values, so they have multiple names. And we add our arguments, and that works the same as multiplying. All right, for dividing, it's very, very similar. So dividing is going to look like z1 divided by z2. That's going to equal, well, instead of multiplying my modules, I'm going to divide them. I'm going to have r sub 1 divided by r sub 2. We're going to multiply again, and we'll have our cosine value. This time we're going to take our arguments and we're going to subtract them. So we have theta sub 1 minus theta sub 2, it's important you delineate between which is which, because whatever's on top is going to go there, whichever one's on bottom is going to go there. All right, and then we have plus. What I do to cosine, I do to my sine, so I have I times sine of theta sub 1 minus theta sub 2. That's it. So multiplying and dividing are eerily similar. All right, the only difference is when I multiply my modules. When I divide them. Everything stays the same except for multiplying, add, subtract, subtract. So if you know one, you should immediately know the other one. Okay? But that's it. That is multiplying and dividing. We're just going to real quick do 2 examples of it. It shouldn't be hard because it's basically plug and chug. So if I have z1 times z2 and I actually have real values for these this time, we just plug it in that equation. So z sub 1 times z sub 2 is going to equal, I'm going to multiply my modules, so that would be 6 times 2. I'll have cosine, and I'm going to add my arguments, so that would be 2.4 plus 1.8. I'm going to do the same thing for the sine value. Ooh, I should probably add a plus in there. Plus I times sine of 2.4 plus 1.8. And I bet you a lot of you already beat me at this is 12 times cosine of 4.2 plus I times sine of 4.2. And a lot of this can just be done in your head. As long as you know the formula, I can go, oh, 2 times 6 is 12, 2.4 plus 1.8. So a lot of times I'll just do these in my head because it's not usually crazy hard math. All right, that's multiplication. Multiply our modules, add our arguments. Multiply, add. And I always keep that straight because multiplication is repeated addition. So that tells me the multiplication goes with the addition. All right, let's go do the same thing for division. If I'm dividing z sub 1 divided by z sub 2, so rather than multiplying my modules, I'm going to divide. So we have 6 divided by 2. Then we're going to do our cosine. Rather than adding our arguments, we're going to subtract them. So it's going to be 2.4 minus 1.8 plus I times sine of 2.4 minus 2.8. 1.8. And that's just going to equal 3 times cosine of 0.6 plus I times sine of 0.6. Fair enough, right? Let me talk about this really quick. This is my solution if I don't ask for a specific form. Because if I put it in trig form, and I don't tell you what form to be in, just give the answer in trig form. However, in your homework, and possibly on my test, I might say, give this answer in A plus BI form. So that would be rectangular form. Not hard to do. We're going to practice it on a little later. But all you have to do is, in your calculator, put in cosine of 0.6, multiply it by 3, you have your A value. Take 3, multiply it by sine of 0.6, so it'll be whatever you came out here plus whatever you come out here, I. And now you have an A plus BI form. Okay, not hard. Not hard, just look out for that for the question. Okay, make sure you answer the question the way it was stated. Okay, we're going to talk about conjugate really, really quick, because it's a super easy process once we see it once. So a complex conjugate of, if it's in rectangular form, is going to be A minus B I. And we've used it a lot. And the whole point of the conjugate is when I multiply it together, it gets rid of that imaginary number. That's the whole goal of the conjugate. Our conjugate, if it's in trig form, and we'll see how this works on the next example, is going to be eerily similar to what we have, except we're going to have r times cosine of negative theta plus I times sine of negative theta. All right, so we just change our thetas to negative. In other words, we just switch from positive to negative or negative to positive, and that becomes our conjugate. Like I said, our next problem is we're going to multiply something by its conjugate. The goal of a conjugate is to get rid of the imaginary portion. So we're hoping that works out. And in fact, it's going to work out so nicely, we're going to do all of this work, but you're going to find out next time you do it, it just is one step. Once we see the answer, we'll see that we can just do this in one step. So this is find the product of 2 times cosine pi over 3 plus I times sine pi over 3, and we're supposed to multiply that by its conjugate. So let's go ahead and do that. So first thing I'm going to do is I'm going to rewrite what I have. So I have 2 times cosine of pi over 3 plus I times sine of pi over 3. Its conjugate, so we're going to multiply by its conjugate. The conjugate is going to be cosine of negative pi over 3. Maybe I should put those in parentheses because we have negative signs. Plus I times sine of negative pi over 3. We're going to multiply just like we did on the other side. We multiply our modules, so that's 2 times 2. Let me write it all out. So that's going to equal 2 times 2. And when I'm multiplying, we add our 2 arguments, so that's going to be pi over 3 plus negative pi over 3 plus I times sine of, once again, it's pi over 3 plus negative pi over 3. So I did what I was supposed to. When I multiply my modules. I add my arguments. So that's my 2 arguments. Well, 2 times 2 is 4 last time I checked. I haven't checked recently, though. That's going to equal cosine of, that's 0. Plus I times sine of, that is also 0. Now I just have to think back to my unit circle. So we will need our unit circle for this one. Not for this particular problem, because you should know the cosine of 0 and the sine of 0, because it's right here on the unit circle, right? Our x value would be 1, our y value would be 0, so that means our cosine is 1, our sine is 0. So to simplify this, we'd have 4 times 1 plus, well, that's going to be 0 i's, so I got rid of my zeros, or my i's I should say. We distribute that 4. 4 times 1 is 4, 4 times 0 is 0, and we're just left with 4. So in fact, the only thing I'm left with are my 2 modules. But it just so happened my module has to be the same when I'm talking about the conjugate. So that 4 is actually just r squared. That is the only step you have to do when you're multiplying the conjugate when it's in trig form, is you just have to square this number. So if this is in trig form and this was a 6, I don't care what's written in here. This could be 3,000 pi over a billion. I don't care what's written here. As soon as it says multiply by its conjugate, your answer would be 6 squared. If this is 6, it'd be 6 squared. If this was 10, it'd be 10 squared. So on the test, don't scribble this out because it's good to see the work. But on the test, this is all the work you'd have to... Let me just go ahead and erase it. On the test, if you know what you're doing, I'll show you all the work you need. That is all the work you need on a test if I ask this question. Okay? But that's if you know it. If you don't remember that, then you're back to doing all that. So a person that remembers this, person that doesn't remember this. All right, so it's semi-important. It could save you some time. That's why I circled it. Okay, we just have one more example to go. It's a little bit of a lengthy example, and just because of the explanation. It's mostly just the explanation, because you can do this a lot faster than I can while explaining. All right, and I shortened this question off in the beginning, because I'm going to show you my thought process in a problem like this. Okay, so we have two complex numbers. They aren't in trig, they're in rectangular form. But it goes on to say, use trig form to find... Well, I didn't even finish reading that question. In my head, I read use trig form. These are in rectangular form. So before I even read what the question is, I know I have work ahead of me. I have to first put them in trig form. So before I even start the problem, we must find the trig form of each. All right, trig form is with the cosine and sine. In order to find our trig form, we need to have an r value and we need to have a theta value. So those are the two things we need to find for each of those. The easier of the two is going to be our absolute value or our r value. I'm going to go ahead and call it ABS, stands for absolute. I guess I could put a value on there. So we're going to find our absolute value first. Just like our magnitude, I always do this first. Let's just let r stand for absolute value. So we're going to say r is going to equal the square root. It's going to be the square root of a squared plus b squared. For z sub 1, my a is negative 2. So we're going to do negative 2 squared plus my b. Don't get confused here. All right, because the I is in between, we can move that I over there to say our b is 2 times square root of 3. So our b is 2 square root of 3 squared. Remember, in all these formulas, we never use I. I is like a placeholder that I start with, and it'll be a placeholder when I get down here, but I never use it in my equation. Well, that's just going to equal 2 squared is 4. Plus, and how I always do these is I do 2 squared is 4. Square root of 3 squared is 3, so it's going to be 4 times 3, which gives me 12. And the square root of 4 plus 12, 16 is going to be 4. That is my absolute or my r value. The next thing I have to do is I need to find my theta. Well, I'm going to use that method that we came up with yesterday. That I know that a equals r times cosine of theta. Well, my a value is that negative 2. So we'll have negative 2 equals r is 4 times cosine of theta. Rewriting that, I would divide both sides by 4. We'd have negative 2 over 4 equals cosine of theta. Do cosine inverse of both sides, and you're going to see that theta is going to equal cosine inverse of, I'm just going to change that to negative 1/2 instead of 2 over 4. Doesn't matter, you could have left this 2 over 4. You're letting your calculator do the work anyway. Real quick here, before, I'm trying to see if I'm going to have room. I wrote this a little smaller last time. Let's just get our answer. So this is going to come out to 120 degrees. So we have our theta, and we have our r values. What I want to do really quick is I want to make sure that 120 makes sense. Because like I said, I didn't do a drawing, so I just want to double check to make sure 120 degrees makes sense. So what I would do is I would do a little drawing off to the side. Not accurate at all. All I'm going to say is, okay, my a value is negative 2, my b value is 2 squared of 3. So that means my x value would be negative 2, so I'd go over here and I'd come up some. Doesn't matter, we're just trying to make sure it didn't find our reference angle. That looks like 120 degrees would work, right? Because my reference angle would have been 60 degrees here. This is definitely not 60, so 120, I'm good. That's the right theta. So that little drawing just checks to make sure you did the right theta. That's all I do that little drawing for. And now we just plug it in. So our r value was 4. So our trig form is going to be 4 times cosine of our theta, which is 120 degrees, plus I times the sine of 120 degrees. Okay, we're going to do the next one a little faster, just because this should be mostly review because we did this for homework. Our absolute value. Our absolute value is going to be R equals the square root of our A value, which is square root of 3 squared, plus, there's a 1 hanging out there in front of the I, you just can't see it, but it's 1 squared, right? There's a 1 here, and so it's 1 squared. Well, square root of 3 squared is 3, plus 1 is 4, so this is square root of 4, which is going to equal 2. Our R value is 2. Let's go ahead and get our theta. Maybe I'll put theta down this time so I know what I'm finding. Our theta, we're going to use that A equals R times cosine of theta. Our A was square root of 3. That's going to equal my R value, which is 2, times the cosine of theta. I would divide both sides by 2, so I'd have square root of 3 over 2. I would do the inverse of cosine, so we're going to end up with theta equals inverse of cosine of square root of 3 over 2, which is going to be about 30 degrees. 30 degrees looks like it could be a reference angle, right? Because 30 degrees is a small angle. I just want to double check to make sure this isn't a reference angle. So once again, you can either write it out or you can just picture in your head. Our A value is square root of 3, our B value is 1. So we're going to go out square root of 3, come up 1. So maybe there's a point about here-ish. Well, hey, 30 degrees makes sense here, right? 30 degrees wouldn't be the reference angle, so 30 degrees works. Like I said, if our angle would have been over here, 30 degrees wouldn't have made sense. That would mean that I'd do 180 minus 30 degrees. Okay, does that make sense while we do our drawing? Most of the time they'll be right. Most of the time this will be 100% right. We just want to check for those 1 or 2 times where it is not correct, where it's actually a reference angle. Okay, so that means I have my R value, I have my theta value, so we're going to have 2 times the cosine of 30 degrees plus I times sine of 30 degrees. All right, so I put it in trig form. It goes much faster when you're doing it on your own, and I'm not stopping every 5 seconds. Okay, so we have our 2 things. Now I'll continue my question. We're going to use the trig form, got it, to find, oh, we're just multiplying them. We're just going to multiply them. And I'm going to tell you, we're going to also put them in form A plus BI, just like our homework is going to have. So we're going to put this one in form A plus BI. All right, Z1 times Z2. First thing we're going to do is we're going to multiply our modules. And our modules are 4 and our 2, so we're going to have 4 times 2. So we're going to do that equals 4 times 2 times the cosine. Now we're going to add our arguments. That just means add our thetas. This was 120. That's 30, so it's going to be 120 plus 30. And that's going to be plus I times the sine of the exact same thing. I'm getting I wrote a little big here, plus 30. Finish off. Do some simplification. We're going to have 8 times cosine of 150 plus I times the sine of 150 as well. Now here is the problem. I said we're going to put it in form A plus BI, so we have to go further. The next thing I'm going to recognize is cosine of 150 is a very specific answer. It is on our unit circle. 150 is on our unit circle. Does anyone know what the cosine of 150 is? So we should probably take our unit circles, or find, you should have a unit circle that's just floating somewhere. How about I just give you the answer? Oh, what do you got?
Is
Anyone? Just.
is negative square root of 3 over 2.
Yep, is negative square root of 3 over 2. So this is actually going to equal 8 times negative square root of 3 over 2. Plus, well, the good thing is, if cosine is square root of 3 over 2, that means sine is 1/2. I just got to figure out if it's positive or negative. It turns out it is positive. We're going to distribute our 8 to both pieces. And we're going to come up to negative 4 square root of 3 plus 4i. So we will need our unit circle for some of the problems. We're going to finish out class by finishing this one. You guys are going to finish it out. You should end up with just 2i should be the answer.